Hi everybody, I am B.S. Patil, Government First Aid College, Dharwad. Today I am going to explain power supply and waveform formed in the cathode ray oscilloscope, followed by the mention of uses of cathode ray oscilloscope as per the Karnataka University syllabus. In previous session, while explaining operating voltages in CRT, we have seen that different voltages are required. These voltages are obtained from power supply. There are two power supplies, a negative high voltage and positive low voltage supply. These voltages are generated in the CRO itself. The positive low voltage supply is from plus 300 volt to plus 400 volt. The negative high voltage is from 1000 volt to minus 1500 volt. So this voltage is passed through a bleeder resistor at a few milliampere. The intermediate voltages are obtained from the bleeder resistor for intensity, focus, and positioning controls. Now let us see the different parts of the cathode ray oscilloscope. So this is a display formed in the cathode ray oscilloscope. So here time base is there. So these are the Y gains. So these are also called volts per division in terms of volts per division. So two channels are provided to give the signal. Now let us see the waveform in the CRO screen when the DC voltage is applied. When DC voltage is applied to the horizontal deflection plates, the spot moves either to the left or to the right. If H1 is positive, spot moves to the left because the electron beam is attracted by the positive plate and repelled by negative plate. Similarly, by applying a DC voltage to the vertical deflection plates, spot can be moved up or down. If voltages are applied to both the sets of plates together, spot can be placed anywhere on the screen. So this is the display of the waveform on the CRO screen when DC is applied to the horizontal deflection plates. So now we can see when AC voltage is applied to these plates. So when sinusoidal AC voltage is applied to horizontal deflection plates, the spot also moves to the left and right. Since the frequency is very high, so very high means if we are considering the 50 Hertz frequency, the time period comes out to be 20 millisecond. So and also due to the persistent property of the screen, it is not possible to the human eye to see the motion of the spot distinctly. Thus, what we can see? We can see a solid line as shown in the figure. In figure B, we can see solid line trace even if sawtooth AC voltage is applied to horizontal plates. But the difference is the electron spot which is tracing the solid line moves from left to right at a uniform speed because the voltage is increasing linearly. It was not so in the case of sinusoidal voltage. When sine voltage is applied to vertical deflection plates, that is Y plate, and the same time a sawtooth wave voltage is applied to the horizontal deflection plates, the waveform formed as shown in this figure. So when a sawtooth wave is applied to horizontal deflection plates, the x-axis on the screen is taken to represent time. Thus, this voltage is called time-based voltage. So in the figure, you can see an ideal time-based and actual time-based voltage. So in actual case, it takes a little time for the voltage to fall from the maximum positive to maximum negative. So this time interval is called flyback or retrace time. So due to this, the waveform is little distorted as shown in the figure. Thus, the path traced by the spot during the flyback period is called retrace path. This retrace path does not give a good visual effect. Therefore, in most CROs, the electron beam is blanked off by applying a negative voltage to the control grid during the flyback period. Dear students, you can see now the uses of the cathode ray oscilloscope. So cathode ray oscilloscope is to study the waveforms of alternating potential difference. To study this, the signal is fed to the Y input. The size of the figure displayed on the screen can be adjusted by operating gain controls. The time-based frequency can be changed to accommodate one or two or more cycles of Y input. So for the measurement of voltage, we have to see vertical attenuator setting, that is volt per division, and the peak to peak deflection of the beam, that is number of divisions. Then the product of attenuator setting and number of divisions gives peak to peak voltage. So by dividing it by root 2 gives RMS value. Suppose for a waveform vertical attenuation is set to 0.5 volt per division and number of divisions is 3, that is from peak to peak vertically, then the peak to peak voltage is 0.5 into 3 is equal to 1.5 volt. For the measurement of period, time per division is multiplied with number of divisions per cycle, that is consecutive peak separation. Then reciprocal of time period gives frequency of the signal. So CRO can also be used to study the output waveforms of various signals. So in the medical field, CRO have wide applications, that is for displaying heartbeat rates, nervous reactions, etc. So in radio stations, voltage and current waveform can be observed to take necessary decision. So this device is used to check AM and FM circuit characteristics. So phase difference can be calculated by analyzing the Lissajous pattern. In hysteresis loop, it is used to find BH curves. Thus, no other instrument used in the electronic industry is as versatile as the cathode ray oscilloscope. So this is all about the formation of waveform in case of the cathode ray oscilloscope and also the applications of cathode ray oscilloscope. Thank you.